Okay, everyone, welcome back to our statistics class notes. We're in section 8.3 on page 128, and we're talking about some details about hypothesis testing to wrap up our chapter 8 on hypothesis testing for population proportions. Okay, so in example 151, I want to do an example where we talk about the two different types of errors that we just went over in the last video that we can make. So suppose a Flagler College student is working on his stats project and is interested in predicting whether the majority of Flagler College students support co-ed dorms on campus at a level of significance 0.05. Okay, so state the null and alternate hypotheses. Okay, so the null is that P is equal to 0.50 because what we're trying to show is majority, the alternative, which is that P is greater than 0.50. Remember, always an equal sign in the null, and we want to show alternatively that P is greater than 0.50. This is what we're hoping we can get data to demonstrate. Now, one error the student could make would be to reject the null hypothesis when it is true. This is called a type 1 error. Okay, if you go back up to this table, this is reject the null when it's actually true. That's a type 1 error. This means we would actually conclude the alternative, which is that more than 50% of all Flagler College students, or the majority, support co-ed dorms, when the actual proportion of Flagler College students who support co-ed dorms is really 50% or less, because we should not have rejected the null. The other error that a student could make would be to fail to reject the null when it is false. Okay, that's the type 2 error. We fail to reject the null when it is false. So in other words, we say we should have realized that we had enough evidence to support the alternative, but we do not reject the null. So that means we would conclude that 50% or less of all Flagler College students support co-ed dorms, but the actual portion would be our alternative hypothesis, which is that more than 50%. Okay, that's a type 2 error. The 5% significance level means there is only a 5% chance of making a type 1 error, and that's what we try to control with alpha, the significance level. It tells us the chance of us making a type 1 error. That is, that the student mistakenly concludes more than 50% of all Flagler College students support co-ed norms, when in fact they do not. Okay? Now, how do we reduce the possibility of making it? The only way to reduce the probability of both types of mistakes is to increase the sample size. Increasing the sample size improves the precision of the test. We get a smaller standard error, which is standard deviation, so we get more precise, which helps us make mistakes less often. Now, always remember, you just don't want to keep making that level of significance, alpha, arbitrarily small, because that increases the probability of making a type 2 error. So you alpha is just based on what are we willing to risk about a type 1 error. It's got nothing to do with a type 2 error. The way to make both mistakes probability of going down is to increase the sample size. That increases our precision. All right, the last thing I want to talk about is not the last thing, but the last thing about understanding some minor details about hypothesis testing is to understand the difference between statistical significance versus practical significance. So a result is statistically significant when the null hypothesis is rejected, because that means we had enough data to go ahead and say that we should reject the null and support the alternative. There was statistical evidence to support the alternative. That's statistically significant. The difference between the data estimated value for a parameter and the null hypothesis value for a parameter is so large it cannot be convincingly explained by chance. That's what happens when we were rejecting the null. However, statistically significant findings do not necessarily mean the results are practical. And the easiest way to see this is through an example. Suppose the proportion of people who get a certain type of cancer is 1 in 10 million, and that a statistical analysis shows that regular exposure to a certain common type of plastic doubles the risk of getting cancer. Well, what would that mean? That means we go from 1 in 10 million to a 2 in 10 million chance of getting cancer. Even though that's doubling the risk and it's statistically significant, really we should not make that practically significant to our lives, because going from a 1 in 10 million, very, very low chance of getting cancer to a 2 in 10 million chance of getting cancer is not practically significant. That is not a significant amount of increase. So hopefully that would not cause you to stop using that type of plastic, and it shouldn't, because practically speaking, it's not that big of an increase. A practically significant result is both statistically significant and meaningful to us in practice.